For homework, first I want you to look at the homework 1 module, and there I want you to implement a Mary era style monetary policy, minting policy. So in Mary, it's already possible to use native tokens, even though we don't have Plutus. And you can specify minting policies, but only of a relatively simple type. And what you can do is you can specify signatures that have to be present in the minting transaction, and you can specify deadlines. So you can say that minting must not happen after the deadline has passed. And there's more you can do. You can also combine several such policies with logical AND or OR. What I want you to do here in the homework is to implement a minting policy that has two parameters, a pub key hash and a POSIX time. And the idea is that minting should only succeed if the transaction is signed by the corresponding signature and if the deadline has not yet passed. Then you have to implement the depending things like the policy and currency symbol accordingly. Now for the off-chain code, I already implemented that. So as parameters for minting, you must provide the token name, the deadline, and the amount you want to mint. And then in the mint contract, I first look up my own public key hash, as I explained before. Then I use current time to look up, as the name suggests, the current POSIX time. I look up the deadline from the parameters. And if the deadline has already passed, then I just log an error message. So I don't even bother submitting a transaction because I know it will fail anyway during validation. However, if the deadline has not yet been passed, I compute the value I want to mint, so just using the currency symbol, the token name, and the amount. Then in the lookups, I must specify the minting policy. And finally, in transaction, I need two constraints that I combine, so that I want to mint the value in this transaction and the validity interval. And recall, normally the rule of thumb is to make it as large as possible, but not too large, of course. So because in the validation, it will be checked that the deadline has not yet passed. The largest interval I can basically use is toDeadline. And then I submit the transaction, wait for confirmation, and log the message that I forged the value. Then the usual, I define the endpoints in terms of this mint contract, do the playground boilerplate, and then I also provide an emulator trace, token name ABC, deadline beginning of slot 10. I only need one wallet. I start the endpoint on wallet 1, and I immediately call mint 555 tokens, and then I wait until slot 15 or for 15 slots. So now the deadline, which is slot 10, should have passed. So the second minting should fail, and I wait another slot to see the effect. However, when I try this trace in the REPL and check, then I get an error for the first minting. And this is not coming from the log message, but it's really coming from validation. So we see a validation error, deadline missed, which is the error message that I use in validation. So I was puzzled a bit by that, and then I finally understood what the problem is. So the off-chain code is wrong, and the reason is the switch from using slots to measure time to using POSIX time to measure time in Plutus. So recall that validation works by checking that the validity interval is contained in the toDeadline interval. So that's what it means. We must check that the deadline has not yet passed. No matter what the current time is, we don't know for sure. We just know it's somewhere in the validity interval. So the whole validity interval must be before the deadline, which means it must be contained in the toDeadline interval. And that's why here, when I set the validity interval, I use toDeadline. And I thought that's obviously correct, because obviously toDeadline will be contained in toDeadline. However, what I forgot was that the underlying transactions, the Cardano transactions, still use slots. So even though Pluto switched to POSIX time, the transactions still use slots. So for example, if the deadline is the beginning of slot 10, somewhere in the beginning of slot 10 or the very beginning of slot 10, then this interval to beginning of slot 10 in the real transaction must be translated into a slot interval. And that will be the interval that goes to slot 10 inclusive. So all of slot 10 will be in the validity interval of the actual transaction. So now during validation, that is again Pluto's, this validity interval will be translated back into a POSIX time interval. But now, because the slot-based interval includes all of slot 10, when that's converted back into POSIX time, we will get the end of slot 10 as the POSIX time, not the beginning. And that means validation will fail because now suddenly the validity interval is larger than the to deadline interval, because the to deadline interval stops at the beginning of slot 10, but the validity interval now only stops at the end of slot 10. So that's a bit unfortunate and might lead to subtle errors. So one really has to be aware of that this conversion happens. So Pluto's works in POSIX time. Transactions are based on slots. So when we go from off-chain to on-chain code, this conversion happens twice. The POSIX time gets translated into slots in the transaction, and then during validation they get translated back. And because slots are of course much coarser grained than POSIX time, this conversion is not perfect, so it's lossy. So that means if we start with the POSIX time, convert to a slot, and then back, we won't necessarily get the original POSIX time back. So that's what I overlooked. And let's try to fix that. I honestly don't know what the best way is. One way is, instead of using to deadline, to just use a time that's a bit in the future from now, and then hope that we are not too close to the deadline, so that goes past the deadline. So for example, what I could do is I use now and add, I don't know, 2 seconds, something like this. So this gives the transaction 2 seconds to get to the validating nodes, which should be enough, I think. Maybe we could make it 5 seconds. I don't know actually how long it would take. And the larger we make it, the higher the risk that if you're close to the deadline, then this now plus 5,000 is after the deadline. But the smaller we make it, the faster the transaction has to be distributed to all the nodes. So I'm not exactly sure what the best number here is. Of course, for now, if we just simulate it, it doesn't matter because there is no delay, no network delay. So we could use this. So I made the same change in my sample solution, and if I run the emulator trace in the REPL again, then I get the desired result. So here in slot 1, I mint and it works. And when I try in slot 15, it doesn't, but the transaction doesn't even get submitted. I just get the log message from my mint contract that the deadline has already passed. But now, because I used 5 seconds slack, basically, if I tried minting too close to slot 10 when the deadline passes, for example in slot 8, it would also fail. It would fail during validation. But of course, in a realistic scenario, the deadline wouldn't just be 10 seconds in the future. It would be, I don't know, a day in the future or so, to give you enough time to mint what you want to mint before the deadline passes. As second homework, I want you to slightly modify the NFT contract that I demonstrated by making the token name fixed and just fixing it to the empty byte string. So we don't need the token name as parameter any longer. We just need the UTXO that's supposed to be consumed. So I want you to implement this and also the corresponding minting contract, which you can just adapt from the one we had in the NFT module. I also provide a test emulator trace where I just activate the contract for wallets 1 and 2 and then call the mint endpoint. The advantage of this way, fixing the token name is that you don't need any arguments for the mint endpoint, because the only argument we had before was the token name. So now it's just unit. And if we try this out in the REPL, it works as expected. So we get the two minting transactions, and wallet 1 and wallet 2 end up with a shiny new NFT, but it's a different one. The two are distinct because the currency symbols are different. And you see the token name in both cases is the empty byte string.